जौजलपा सकसिता ठाउँ नेपाल सम्पत जिन्सस ओ पिसोड सिलाथोपुनी अले सन् 2023 फेब्रुअरी 5 तारिक विक्रम सम्पत 2079 माघ 22 गते आइतबार वर्ल्ड नेवा अर्गनाइजेसन पाके ह्यावे चंगु ह्या निथाय प्रसारण ठो WDB गुकेटा वर्ल्ड नेवा अर्गनाइजेसन डेली ब्रोडकास्ट या ठो एब्रिभिएसन फर्म का ठुकु खलाबला ज्याजोले सकलसित सोकुमी पाजुमे जुपिन्ट नरेश शाक्य पाके तस्को छ याना चना WDB खलाबला ज्याजो चिपिस नेपाली कथा वंश गुटा इले WNO यागो फेसबुक पेज वो जुमे लाइभ स्वेदी फै अले ठुकिया रिकर्डिङ WNO यागो फेसबुक पेज चिपिस न्याब्लेन स्वेदी फो WDB खलाबला ज्याजो या मु आज ख चिस हलमे निंक ठिठी ठासे ठिठी खेले ज्याना विशेष के हासिल या टुकुपी जिन्युवा टेटा थन बना वेकअप सयाना वेचंगो ज्या वेकअप सयाना वेचंगो योगदान वेकअप निको एक्सपर्टिज जिसना सिकेको ढका बिचायना थोडेकाको छौ प्लेटफर्म जला अले थन चिसा ठुको प्लेटफर्म ए वेकअप सयाना वेचंगो ज्या चिसा सिकेको कुटो यागो वेकअप सयाना वेचंगो ज्या या बारे चिसा खयाम फटे सिकेको चिसा कुटो यान्छ जला आ ठौ ठु ज्याजोले चाहिँ छिकमी पाके छौ विशेष ओजन फनचना छ कि ठौ छि पाक डाक्टर एलेना श्रेष्ठ वेकअप खैगला थन चाहिँ मचाबले थन नेपाल अमेरिका थन चाहिएको ख अनि अनले प वेका चाहिँ छौ स्कुलिङ जुल अनवया चाहिँ कलेज चाहिदिल अन थoi करियर चाहिँ फोकस दिल एजो कारनाइना चाहिँ तो निवा भा खलाटा पचा वेका ठाकुको ज्या जुन खेरला छिटा चाहिँ WDB वर्ल्ड नेवा अर्गनाइजेसन यो ज्याजोले चाहिँ छा नेवा भा खमलासे मेमे भाषा छ्या छेच्नोट काना छिटा चाहिँ कम्प्लेन मोगला मखो तर झिउ चाहिँ मुख्य आज सुरु ढाबले चाहिँ जिसा थना सतपी पाहापिनी पाखे बुन्न वेकअप सेना वेच्नो ख फयाम फटले वेकअप न्यू जायो बारे इन्फर्मेशन्स म सिक्यु इन्फर्मेसन छ मुका ठेर आर्के बिया छु मु उद्देश्य ख छु मु आज रे ठोजुल एजिया चाहिँ जिसा चाहिँ छौ हिसाबमा ल्याङ्ग्वेज यो ब्यारियर एम्बल लासा गु ढामाउ चिज का वो ढामो फुइगु अथवा जिसा गु खचिसा सिके मागो का वो सिके मोफुइगु जुगली जिसा ठो आ ल्याङ्ग्वेज यो ब्यारियर मडसे पाहापिट छु अपल वे कठन जिसा खलागु yana tuna yana waya tuna kudu we ko eju kana chikpinda mochi thenso sa moto thenso sa chikpina tana ji pel tak na ban chiki ba kya ojang phana chana to mio tha विशेष na to अंग्रेजी भाषा खला जी अले एडी chikpinda moto ka chipsa question nya sa te di fo chisa चाहिँ ji futale चाहिँ nya भाषा ना chikpinda thiki kuda ya एडी chikpisa moto ka sa nya sa wal dhasa ga magala a thong etho jigu tho pha kha वेका एरोस्पेस इंजीनियर Dr.Elena Shrestha वेका थम न्यू जेनेरेशन निमपति सम धामदासा चाहिँ युवा वैज्ञानिक ढासना जिल्ला वेका एटा जिसा शिवजी अपयना चाहिँ इंजीनियर ढाला चाहिँ जिसा मेकानिकल इंजीनियर इलेक्ट्रिकल इंजीनियर सिभिल इंजीनियर कंप्यूटर इंजीनियर चाहिँ निना वेस्नो दु अपयना चाहिँ एरोस्पेस इंजीनियर छुकरेगा चाहिँ सायद मुशिवजी खेला जिसा वंगु वाले ना जिसा पाँचमा बनायो ख एरोस्पेस इंजीनियर ख वेका न पाजो राजीव श्रेष्ठ वंगु वाले ख आठ ठोना एरोस्पेस इंजीनियर न एरोस्पेस इंजीनियर जला आ वेकै पाके छ यको खसी के एरोस्पेस इंजीनियर छुकरेगा होला अले वेकै चाहिँ छौ शैक्षिक योग्यता हिसाबमा वेकला चाहिँ सन् 2012 चाहिँ एरोस्पेस इंजीनियर वेकला चाहिँ ब्याचलर्स सेना दिएको अले अनलेपा चाहिँ थो युनिभर्सिटी मेरील्यान्ड जिल्ला अले सन् 2018 वेकला युनिभर्सिटी अफ मेरील्यान्ड वेकला चाहिँ मास्टर्स व PhD एरोस्पेस इंजीनियरिंग यान दिएको जिल्ला वेकयो चाहिँ स्पेशलाइजेसन चाहिँ रोबोक्राफ्ट रोबोटिक वेकयो अले आछिपिसन याबे CSUG तो हवाई जहाज अनवे चाहिँ हेलिकप्टर वलसिन खना वेच नौ ख आ वेकला याना वेच को अजवे थे या वेकियो जाका कुवेटा साइक्लोकॉप्टर ढाउ या वेकयो पनि छ अनुसन्धानी विषय जिल्ला आठो साइक्लोकॉप्टर ढाउ छुकले चाहिँ वेका पाखे सिकेको जी अले वेकयो जाई अनुभव हिसाबले आकाश वेकला पोस्ट डक्टरल फेलो अले भिजिटिङ रिसर्च इन्भेस्टिगेटर वेकला चाहिँ युनिभर्सिटी अफ मिचिगन याना जिल्ला आठौने वेका पोस्ट डक्टरल फेलो जे अन जेना वे चंगुडु या वेका चाहिँ डिपार्टमेन्ट अफ रोबोटिक एजेन्ट ज्यानात्मा दिगु ठौने अले वेका चाहिँ जोन हपकिन्स युनिभर्सिटीले चाहिँ एप्लाइड फिजिक्स ल्याबोरेटरी चाहिँ सिनियर प्रोफेसर स्टाफ प्रिन्सिपल इन्भेस्टिगेटर र सेक्सन सुपरभाइजर ज्यान दिटुङला अनि वेका चाहिँ डिपार्टमेन्ट अफ एरोस्पेस इंजीनियर युनिभर्सिटी अफ मेरील्यान्ड ग्रेजुएट रिसर्च एसिस्टेन्ट ज्यान दिला वेकला चाहिँ चाहिँ वेको योको अनुसन्धान या चाहिँ चोसुट तिथि नाजाको जर्नल पिया उकेला पिकान्दिला गुकी जर्नल अफ अमेरिकन हेलिकप्टर सोसाइटी अले इन्टरनेशनल जर्नल अफ माइक्रो एयर भेहिकल्स अले जर्नल अफ एयरक्राफ्ट र फुकोट चाहिँ थाहा चाहिँ कि एरोस्पेस इन्जिनियर नबा सपोर्ट गुजुला आज आसा चिसा वेको नपा वेको इट लस कुसा याना छना जोजोलपा एलेना जो जोजोलपा okay in other people pakai udang phone kane chisa thongsa wekan apa angrezi khalauda ga chai so you are welcome to this WDB program Elena.
Thank you so much for having me here. I'm really excited to be part of this program. I'm also supporting a lot of other programs from NOA, and so I'm really excited to continue with WNOA.
Okay, let's start from your history. So when did you come to the US?
So actually, so my family immigrated here when I was around 7 years old. So very young.
Do you remember anything about Nepal?
Oh, absolutely. Yep, I have a lot of memories from Nepal. I remember actually a lot of things, living in Kathmandu, living in Maru, and all of my family members there and relatives are still there, so lots of memories there.
Where are your family members in Nepal?
So there's some from my mom's side in Tapatali, and then yeah. And then
other?
My dad's side is, or at least when we used to live there, it was in Maru. I hope I'm
Moru,
pronouncing it right.
Okay.
Yeah.
We have some people here from Moru in this now audience and participants. Okay, go ahead. And next question. So after arriving here in the US, then you started schooling, right? And then graduation on a college, and then from schooling to aerospace engineer. So your journey from schooling to aerospace engineer. So can you tell us about your journey?
Sure. Yeah. So my family immigrated here when I was 7, and actually early on I wanted to be wanted to go into the medical profession, wanted to be a doctor, but things changed in middle school and high school when the school that I was attending, we did a lot of field trips to places like NASA. And so in one of my field trips, I saw a lot of videos about space exploration, about rovers on Mars, and that really inspired me to pursue aerospace engineering instead, because I wanted to kind of contribute into understanding of our space and how things work, right? How can we make flying vehicles more efficient? How can we come up with new designs? And so that really excited me when I was in high school, and that's why I tried to when I went to University of Maryland, I pursued aerospace engineering.
So what is actually aerospace engineer? I know that you have made some slides for us. So first of all, in brief, how do you explain about aerospace engineer? Because
Sure.
people know that about a civil engineer and mechanical engineer. Yeah, we have so many people in that field. What is aerospace engineer? What actually aerospace engineer do?
So aerospace engineers deal with anything that flies, right? So any flying vehicle, from helicopters to spacecraft, right? Like space shuttles and satellites, that's all within the domain of aerospace engineers. And I'm actually going to go ahead and start showing some
slides.
You
can start now, right? You can start, right? So you can go slowly and we will watch your slide.
Sure. So I mean, this right here shows really, overview of what aerospace engineering looks like, right? So overall, it's designing, developing, manufacturing, and testing all of these flying vehicles. So from spacecraft, even the Mars rover shown on the left there, from satellites to space shuttles, and then even vehicles that are within our Earth's atmosphere, like aircrafts, like the commercial jets that we all take whenever we're traveling, to airships, to rotorcraft, which was really my specialization. So aerospace engineering is a big field where anything that flies, excuse me, that's what aerospace engineers focus on. And then within aerospace engineering, there are two main, there are two main, branches within aerospace engineering. One is aeronautics. So again, like I said earlier, aeronautics is any vehicle that will operate in our Earth's atmosphere, right? So anything that's not in space is aeronautics. So things like commercial jets, helicopters, or drones, things that are unmanned. And then there's also astronautics, which really deals with space-related vehicles. So things like rocket ships, space station, or even the Mars helicopter are things that an astronautic engineer would specialize in. And so a question that usually comes up is, you have all these vehicles. What exactly do aerospace engineers do, right? And so what we do is we design the different subsystems of the vehicles. So there, as you can imagine, one vehicle has so many different components to it, right? From the propulsion system, like the jet engine, all the way to the wing, to the structures. So aerospace engineers focus on all of that. So for instance, here, one big aspect is aerodynamics. So aerodynamics is understanding, how does the air move along the wing, right? How does the air move along the whole vehicle's body? And so that's a big focus area for aerospace engineering. The other is structures. So when things are flying, right, it's very different from how you would design a car or a ground vehicle, right? Because when you're flying, weight is a big concern. So you want to make the structures as light as possible. So aerospace engineers focus on how can you reduce the weight of each of the structures while still, maintaining performance and improving the efficiency. So trying to make it as lightweight as possible. And then another key area is dynamics and control. And what that means is, how can these vehicles, move in the airspace, right? If there's a building nearby, how do you avoid colliding or avoid hitting the building? How can these vehicles move and be, and then maintain stable flight? So that's a big, I guess, question within dynamics and control. And besides design, aerospace engineers also focus on tests. So testing these different vehicles. And so this is something that is done at the University of Maryland at the Alfred Goodso Rotorcraft Center. So there we have this wind tunnel with large wind tunnel facility where you can mount just one specific rotor or even the whole vehicle inside that wind tunnel and try to measure the performance of these vehicles, right? Like how much force is a rotor or a wing generating, and that data helps with designing these new vehicles. The other thing is collecting data in flight test. So to the right here, this video is like in one of the buildings at University of Maryland, where we're flying the cyclocopter, which I'll talk more about later on. Inside this, this facility with lots of cameras here, and all the cameras logging, the location of this vehicle, right? So how high is it in the air? How far is it moving? How fast is it moving? So all of that data is being recorded, and then what we do is we analyze it. We review it later to measure, to confirm that we're getting that performance that we need, and also to test the reliability of these vehicles. And there are different types of rotorcraft. So again, this is, my specialization is mostly on the rotorcraft side versus, the airplanes or the spacecraft. And even within the rotorcraft, there are a lot of different designs, especially when you go from full scale. So full scale, like, the helicopters that you see, all the way down to when you're talking about these small vehicles called micro air vehicle. And so when you scale down full scale vehicle designed like a helicopter, you've probably seen these radio controlled helicopters, right? These small little toys that a lot of people fly for hobby. So when people were initially designing these smaller vehicles, the first thing that people, mostly think is, let's start by, scaling down like something that we already see, like the helicopter's design. So that's why the first initial iterations of design look just like the helicopter. And then what happened is, as we focus more on the aerodynamics at the smaller scale, you'll see much more variation in design. So instead of a helicopter design, what became really popular in the last decade is this, multi-copter or quadcopter shown here, because these, instead of having all the way, controls on just that one single rotor that a helicopter has, these use multiple rotors, and it's much faster at the smaller scale. And what's really interesting in the last decade is that we're also seeing a lot of unconventional designs. So some things from, this ducted rotor on the left there, to the cyclocopter, which I'll talk about, and also nature-inspired designs like the hummingbird. So these flapping wing vehicles are, very interesting. A lot of designs have been, I guess, developed in the last few years. And I'll show a video of a flapping wing later as well.
Just 1 minute.
Yes.
Just you once one more time. So in simple language, can you explain about a rotorcraft?
Sure. A rotorcraft is just any vehicle that can stay in the air. It's called hovering. So it can, when it takes off vertically, and it stays in the air without having to move forward. So airplanes, right? They can't just stay in the air. It relies on.
Aeroplanes are not rotorcraft.
Yeah, airplanes are not rotorcraft, right? So
okay.
Airplanes, they use their wings, right? So that's why they always have to move forward in order to stay in the air. Rotorcraft, they don't have to go forward to stay in the air. What they do is they spin the rotor instead, right? So the helicopter blade up top, it's spinning, right? And so by spinning the rotor. Sorry?
No, something, just the noise. Okay, I just unmuted.
Oh, sorry. Okay.
No problem. Go ahead.
So by spinning the rotor in the air, it generates enough force, right? It supports the weight of the vehicle, so it doesn't have to move forward. The air is already spinning.
Wait. Birindu the question sunya saduka.
Junior sir to get an Sonia Sun University or with it.
La Luna Disal Chita Tickets.
Mobile Julie.
And you thought today.
Juzalopa, Dr. Elena. Yeah, I'm Birendra from UAE. I'm from Nepal also. I'm working in the UAE. Okay, I have a few years of working in the aeroplane. Small knowledge I do have also. This you have mentioned as hovering. This helicopter can hover in the air up to which altitude?
Right. So these helicopters, they can go up to maybe 15,000 feet. Usually it's not as high as airplanes, right? So typically at least half. The normal operating altitude is around 10,000 for most of the helicopters. Some can go higher, especially if they're, a little, if they're designed to go for a higher altitude. But you're right, they don't go as high as airplanes.
Thank you.
Okay.
Did I answer the question? Usually around 10,000 feet is where, less than that, typically less than that. So that's the highest, that's usually the top operating for helicopter.
Thank you
so
very much.
You'll normally see, oh, sorry, go ahead.
No, I'm just requesting to all the audiences here. So me pas mes biji chikpin nyasa da satan lal duna desa la biche laluna desa jo nyasa devile ji chikpin चाहिँ palam pa चाहिँ pa biji. Okay, Dr. Elena, go ahead.
Sorry. Yeah. Okay. And so the question usually is, as you look at these smaller vehicles, right? These and then, so when I say small vehicles, I'm talking about, they can either fit on your hand, or like maybe the size of your laptop in length or width, right? And so the question is, when you have these small vehicles, what can you use them for? And so there are multiple applications. So the best one, immediate one that comes to anyone's mind is for search and rescue, right? When it's a very dangerous condition during disasters, and so typically you don't want to send humans there, and instead of that, you can send these small drones, basically, to try to search and for people, and so that they can so that humans can actually go in and rescue them. So the other major one in the last few years has been agriculture. So farmlands, they're very huge, right? There's a lot of maintenance work that's required, and so instead of having humans go through and try to maybe like spray the crops or monitor the different crops, what's happening is that people are trying to use drones instead. And related to that, is also survey and inspection of infrastructure. So like bridges, monitoring any damages to bridges, or just making sure that the infrastructure is working. There's no issues there. So that's a major one, I guess, in recent years, because it's very difficult for humans. For instance, it's dangerous, right, to go and try to inspect the bridges, and so it's easier to just send in these drones. The other one is package delivery. At least in the US, there are a lot of companies that are working, like Amazon, Google, trying to see if it's possible to deliver packages using these vehicles instead of humans. And the other one is filming. Filming in, a lot of the Hollywood, scenes are actually filmed with drones now, instead of using a manned helicopter. And filming is also useful in dangerous situations, right? Like when you're in the wild, you're not able to get close enough to animals, so you just use the drones instead. And also for security, drones are very useful, especially in isolated areas. Like if you're on a ship in waters, and then instead of sending a helicopter, it's easier to just send a drone. And so at the University of Maryland, the lab that I worked in was called Micro Air Vehicle Lab, and we had multiple different types of vehicles at the small scale. So I mean, if you look at this picture here, the quadcopter compared to like a quarter, like really tiny. These are really tiny vehicles, right? And so rotary wing means that these vehicles they use some sort of a rotor, right? So airplanes use wing mostly, and rotorcraft use rotors. And so rotary wing vehicles are cyclocopter, quadcopter, or a ducted fan. A ducted fan just means, a rotor is covered with a duct or a shroud. There's also hybrid vehicles. So quad rotor biplane. It is hybrid because it has both rotors and wings. So what it does is it can hover like a helicopter. So it can vertically take off or vertically land. And also, if it rotates the whole body, it can actually fly like an airplane. I should have a video of that next. And also bio-inspired designs like flapping wing. So again, quadcopter biplane is a hybrid. So it's combining the advantages, right? Like the pros of using an airplane, and then the pros of a helicopter in one vehicle. So that was interesting video here. Is video lagging, or is it okay?
Yeah, it's a little lagging. Yeah, it happens when you share in Zoom.
Okay. But this is just a flight test in Maryland, where we're just showing the quad biplane's ability to take off like a helicopter, and also transition to higher speed flight as an airplane. And then it can also, again, when it's landing, it just goes back into helicopter mode and can land vertically. So we also worked on a flapping wing vehicle. So this is insect inspired, right? Insects, when they fly, they're flapping their wings at a very high rate. And that's how they generate the force to support their weight, the body weight. And so this is a very slowed down video of a flapping wing.
So you said that you mentioned here 65 gram, right?
Yes, so this is very tiny, 65 grams. And if you look at the picture here, you can kind of see the size difference, right, of how big it is.
Mm-hmm.
So compared to a car key, basically, it's basically will fit on your hand. And 65 grams is pretty big for an insect, right? So that was one of the challenges and why we don't really see these sort of at least at this scale, is because when you're flapping at that high speed, it's very difficult to get enough force to support that weight. So 65 is really at the higher end of what you might see for these vehicles, at least at least in recent years with this type of like a structure that we're using. Was there a question? So there was someone raised
Yeah,
their
here the
hand.
Birendra is raising hand. Okay, Birendra ji.
Yes,
Yeah.
no problem. Dr. Elena, yes, I have seen your videos and presentation. That can you go back to your slide in the hovercraft? Not prior to this video. Yeah, this is BTOL, right? Yeah, this one.
Okay, sure.
Yes, sir. Okay, stop me here. Yeah. This it's very good. This is for humankind. It can be used in many places for the assistance. Now, there is facility, there is improvement, there is good for him, and it can be misused for the other purpose also. So what are the measures for those misuses when it is discovered? How can we use to protect from that? Yes, these are good to use for in our life too, but from backside, from negative side, who's trying to do the wrong thing. So how can we protect that one? And for the unknown person, if something is hovering to us, and how can we protect that?
Yeah, that's a great question, and that is a big question in the field right now, because anytime you have these sort of platforms, right, there are always going to be some people that will try to use it to harm others. And so it's the question is, what do we do? How do we deal with that? And one way that people are dealing with it is trying to heavily restrict the types of the functionalities in the boards that are on these vehicles. So for instance, one of the most popular boards right now, they have an additional sensor that tells air traffic controllers even and like where this drone is, right? So it'll give you the location of a drone. The other thing is whenever you want to fly these vehicles, you have to register this for instance, in the US, it's the FAA, but you have to register the drone. So they're trying to make sure that they have records of who's flying these things. In addition to that, also trying to restrict the board, the functionalities on the board, so that you can't really use it to fly into spaces that are restricted. So, for instance, on some boards, if you fly too close to an airport, the board will actually stop the vehicle from moving forward. So those are things that we can try to prevent or restrict. The other thing is if someone already has their own custom boards, for instance, right, and so they're carrying something that's very dangerous. Typically the only way to stop it at that point is to either counter that drone with another drone, or have other sorts of tools that humans can use to try to stop this vehicle. So recently, people have been making like netted like launchers, like a cannon with a net to try to capture the drone. Other people have trained animals, like birds, to try to attack the drones. And then a lot of people are focusing on counter drones, like building a faster drone that can take down these the ones that are trying to harm other people. So I think it's like in any technology in our life, right? There's gonna be some people trying to use it for bad purposes, and so you always have to try to create countermeasures or ways to prevent that.
Yeah,
I
that's
hope
true.
that answers
Everything
the
can be
question.
used. Yeah, everything can be used for like a bad purpose and good purpose,
Yeah,
right? Every tool
yeah,
can be used. So definitely, this is also
exactly.
a question for this one as a security reason. So I have a question here in a Facebook page. So Nishchal Pradhan, so he asked that very interesting. Any particular insect did you model the flapping wing?
So for the flapping wing itself, we didn't model it after a particular insect. Actually, this variation is modeled after the hummingbird, so it's shown on the bottom right. So hummingbirds are weird in that they don't really fly like a typical bird, right? So if you see like a pigeon or whatnot, they're flapping like straight up and down usually, whereas insects and a hummingbird, they usually you'll see it like flap sideways. The motion is very different actually when you look at an insect versus a bird. And so this particular one, because of the size, because it's bigger than what you'd see for insects, it was modeled after the hummingbird.
And another question from the Nishchal. Any particular ways where flapping wings drones are better than traditional rotorcraft drones?
Yeah, that's a great question. So the reason why you'd want to use this is because it's more maneuverable, right? So meaning that it, unlike a helicopter, insects are very fast, right? They can quickly move around. So if you ever see if you're ever trying to catch a fly, right, or see any insects, right, they're very quick. And that's because a lot of their controls are just, you can control it by just changing that flapping motion, which is quicker than trying to speed up or slow down a rotor, right? Once a rotor is moving, because of the weight of the rotor itself, it takes some time to slow it down or speed it up. Whereas a flapping motion, it's easier to adjust. And so because of that, these vehicles are, I guess, more maneuverable, more agile. So if you could imagine if there's a wind coming, this will have a better chance of staying still in flight or still stable in the presence of the wind. And also if there's when it's going in motion and it comes across an obstacle, it's easier for this to quickly avoid that obstacle versus having to rotate the whole body of a helicopter in order to actually move left or right. So helicopter itself, again, the whole body has to move. Pitch down is what it's called, angled. Whereas this one, it's just you can just quickly change the flapping motion in one direction, and it's able to adjust the motion of the vehicle. Did that answer the question?
I guess so. So Nishchal Pradhan, this is a question from Nishchal Pradhan.
Okay.
Okay, so you can go ahead.
Okay. These are great questions, by the way. And Nishchal Pradhan, I think that's my cousin is asking these questions. It's really funny. And so at my time at the University of Maryland, I actually focused more on the cyclocopter, which you can see here. So cyclocopters are interesting in that, unlike a helicopter, right, where the rotor's spinning along the vertical axis, so it's the cyclocopter is spinning in the horizontal axis. So this motion you can see in the animation here, where you can think of it like a paddle wheel, right? The way it spins, and what we can do here is that we can actually change or control the angle of each of the blades on this rotor. So if you can see and you follow a specific, I guess the airfoil here, or follow the specific blade or the wing, you'll see that the angle is changing as the rotor rotates. And so that's how we're able to generate a net in positive force to support the weight. And some of the advantages of this is that it's more efficient at the smaller scales. It's more maneuverable. So just like, the hummingbird or just like the flapping wing design, by changing the angle of this blade, we can easily change the direction of the force. So that makes this more maneuverable than the quadcopter designs that we've seen. And then because it's also moving or rotating around a horizontal axis, you can imagine that we can transform this into a wheel, right? And so there are multiple modes of operation of the way that this vehicle can move compared to a quadcopter, by just using the same rotor system. But the thing is, this idea of a cyclorotor or cyclocopter isn't really new. In the early 1900s, there were many attempts at creating like a manned cyclocopter. They called it back then cycloidal propeller airship, right? This idea actually originated before the helicopter. But back then, they didn't have the right structures, they didn't have the right knowledge of aerodynamics, and so these vehicles weren't successful back then, and which is why the helicopter design, which is simpler compared to this manned version of a cyclocopter, really became more popular around that time. But the good news is that in 2013, during my master's and PhD at University of Maryland, we're the first ones to create the smaller scale of a version of the cyclocopter, and we're the first to demonstrate stable hover and also stable forward flight. So another interesting thing, and you'll see it in this video, is that for a cyclocopter, it doesn't have to pitch the entire vehicle down like a quadcopter in order to move forward, right? So it maintains the same angle when it's hovering and also when it's moving forward. So that that's another reason why it's able to at least potentially go at a faster airspeed than a quadcopter. So we're the first ones to show that. And towards the end of my dissertation, I also worked on this transformer drone. So the idea is, instead of having just the 2 cyclorotors, we're going to use 4 cyclorotors, and so that this vehicle can convert to ground mode using a landing gear shown here that can either elevate it or so that the rotors aren't touching the ground, or drop the rotors so that it acts more as a wheel. So this is a transformer drone that I worked on. So here's the at least the air mode. So in flight here. So all the forces are generated by the cyclorotors. And then the really interesting one is when you look at the combination, right, of ground mode when it's operating like a car, to the transition where it takes the landing gear, turns on, and so it elevates the vehicle, and then the cyclocopter is actually able to then vertically take off and maneuver like an aircraft, basically. That video is short because of the thing, but you just saw the flight video earlier. But yeah, this is a very interesting design that a lot of people are now looking at, right? In order, with the recent interest in flying cars again and urban air mobility, people are looking at potentially using cyclorotors for those vehicles, for those electric vehicles. And then the other thing is, if you modify the landing gear with pontoons, we can also use this vehicle in aquatic mode, so in the surface mode. So this is just one of the flight or surface mode tests that we conducted at the University of Maryland. So the same controls that's used to fly the vehicle will also enable it to function as a car, as a ground vehicle, and also function as a boat. Okay, so all that is able, all that because of that one, the functionality or the operational capabilities of the cyclorotor itself. But that was my undergraduate undergraduate and graduate experience at the University of Maryland. Since I graduated with my PhD, I've actually been focusing more on robotics, and I don't have a lot of slides here.
I would just like to stop there. The questions from the Lokendra Pradhan here. Okay, and before that, so there's a question from Lokendra Pradhan, and before that, I would like to read one special message for you, and somebody sent you the love for you. Okay, Jojolopa Naresh and watching from Nepal. So good job, Elena, and very proud of you. We love you. Do you know who is he? Your dad, Uday Shrestha.
Yeah, that is my dad, Uday Shrestha. Yeah.
Okay. The question from Lokendra Pradhan is, when would you use a cyclocopter over a normal quadcopter drone?
That's a great question. And so one of the reasons, one of the locations or applications of this would be for search and rescue, right? Or infrastructure monitoring. So because this is more agile, more maneuverable than a quadcopter. So if you can imagine trying to operate in like a small confined space, so like a room that might be damaged, right? So there's a lot of obstacles everywhere. And so you have to have a vehicle that can quickly maneuver and move around the obstacles. And so cyclocopters there definitely have the advantage over quadcopters. The other area, if we're talking about the transformer drone, is when you are operating in multiple domains, right? When you need to operate in like the water, you need to operate in some ground mode or air mode. Instead of having a separate vehicle for each mode, it might be more advantageous to just use a cyclocopter, like the transformer drone. So that's one of the other reasons.
Okay. So there are another message from Nepalese Society for Women in Physics. So Sokumi Bazumi Bitana Tami Tomachi Pahaka, Dr. Elena Shrestha Weka, someone Numo young generation Nugupedia Matama aerospace engineering वैज्ञानिक साइन्टिस्ट जोला अले तनवेकना बखलबले antno जरा tikipini tsunya sa dasa chintna taydifu ale maksudun facebook na taydifu weketa nyuzi ale thom विशेष na चाहिँ thom ji चाहिँ अंग्रेजी खलाबले antno जोला so this is a message from Nepalese Physics Society for Women in Physics, so very interesting and informative, very nice, proud of you. Okay, and there are a couple of messages who are from Morutol. So Urmila Tamrakar, yes, proud of Morutol. Okay, and also Vidyadali, Elena, best wishes from Morutol. So there are so many people in Morutol. And also I saw the one message from Anjana Tamrakar in here, Zoom. I am from Moru, so proud of you, Moruko daughter. Okay, anyway, now. Okay,
thank you so
go
much.
ahead.
Yeah, I really appreciate all the love and support from the community. Thank you so much. Okay, so
So
oh, actually,
yeah, Lotan Manandar. Okay, Lotan Manandar raised hand just now. Okay, Lotan,
Yeah,
question take.
thank you, Naresh.
Uh,
Thank you. It's very interesting. Yes, it's very informative. I just like to know about this cyclocopter. Is it?
Lotan tata gana tai disa.
Yeah, I'm from Lincoln in UK. I'm retired, but I know nothing about this aerospace and all this thing. Anyway, this cyclocopter that you're showing on the picture here, how I mean, commonly people use this. Do they use it now? And if they use, which country? I mean, can we see that in UK? This sort of thing. How commonly they use nowadays?
so that's a great question. This is actually a research platform. So it's not very common, but there have been multiple countries that have been trying to develop cyclocopters. So actually, there's in South Korea, there's a university there that has been making or working on this vehicle since the early 2000s, and they also tried to, I guess, develop a larger scale version of this. There's a company in Japan actually that's trying to create a bigger scale of the cyclocopter recently, and they're trying to make an electric vehicle for urban air mobility as well. And then I also saw that scientists in Russia, right, recently also created this quad version of the cyclocopter. So this is a research platform, but what's interesting is that in the last few years, I'm seeing that a lot more researchers and a lot more countries are starting to look at this design. So who knows, in the future we might see a lot more cyclocopters.
Yeah, and also supposing if someone wants to use it, the cost wise, how much do you think it will cost? Let's say one of the country wanted to buy it or to use it. One is it's a remotely controlled. I mean, it's not a human there, right? So to be able to operate this machine, you need to have the person. You have to train this. Right? That is cost money as well. So the cost wise is how much we're talking about. Let's just say one country wants to buy it.
Yeah, that is difficult to say because we had to custom make all of these in the lab, each of the individual components. It's in the order of thousands, right? And it's hard to say how much labor cost goes into this, right? But the question about having to train a pilot. So towards the end of my PhD, what we were doing was trying to make this autonomous so that we don't need a pilot, right? Trying to focus on modeling the vehicle's dynamics and then coming up with controls strategy so that we don't really need anyone, like a human, to supervise or to pilot this vehicle. So that I mean, I'm not really sure how much labor costs will go into that, right? But I think it would be in the thousands for sure, just for the components if you wanted to just build the vehicle. But
So
it's
don't
hard
need,
to say because this has purely been research. But we should have
you
looked
don't
into
need
commercializing it at some point.
so you don't need the human beings to operate this one then.
Um, so right now we still do, but we're working on like the boards, I guess not board designs, but we're working on the dynamics and controls algorithms, or in order to make it so that we don't need the pilot. But right now we still do, yeah.
Okay, I have many other questions, but I'll give other people a chance. I'll talk later.
Okay, thank you, Lotan Dada. Okay, so you can go ahead, Elena Zhu.
Sure, thank you. I didn't have too much more, so I mean we can easily go into the questions soon. But I'm just going over, what am I working on now, and it really relates to the question that was just asked. So thank you so much. We're focusing more on robotics, and so not the vehicle design side of robotics, but the question of how can we make it safer, right? How can we design the controls for these robots, and so that in the future they can safely operate in the real world, right? So that, for instance, what right now, it's very difficult for robots to operate in spaces that it doesn't already have the map for, or without humans, right? So if you can imagine, flying the cyclocopter inside a cave, right, without a human, it would be pretty much impossible right now, right? Because it doesn't know where, it doesn't know the environment. It doesn't know that it needs to turn left or right because it, in the next 5 seconds, because it doesn't know what's happening in the next 5 seconds. It doesn't have a map. So, the question is, what do you do in that situation? And also, in the real world, robots are not just gonna, interact with each other. They have to also operate in the presence of humans, right? And humans are not easy to predict, right? The motions of humans and what might happen next. So the question is, how do we make robots intelligent enough so that they can safely operate in the real world without a lot of inputs from a pilot or any other human? And so that's the work I'm focusing on at the University of Michigan right now. So looking to combine these 4 key areas of robotics. So sense means, with sensors, how do you sense the world? Plan, given a knowledge of a map, how do you plan around obstacles so that you're not going to hit it? How do you plan your motion from start to goal? And act is easy. It's just how do you I guess, rotate your motors, or how do you move from one place to the other, like physically move? And then the key here that I'm focusing on is learn. So how can robots learn to operate by themselves? How can they learn new, I guess, new information about an environment, new information about things that it might interact with, like people, and then use that knowledge to improve the way it behaves in that world, right? So if you learn something new, just like how humans learn something new, we try to apply it. So the next time we do something, maybe next time we go to a new store, new location on the map, we have a better idea because we learn from our past experience. So that's what I'm focusing on now. Is like, how do we have that same sort of intelligent learning and planning, decision-making capabilities that humans can do and apply it to machines. And with that, that's all the slides I had to show, at least, and happy to take more questions.
Yeah, just I have one question shared from the Facebook. Let me read for you. Yeah, that is also from Nishal. So Nishal Pradhan. So how far is it from commercial production, cyclocopter?
For our lab, it is very far because we never looked into commercializing it. We were thinking of it as a purely research platform because we, when we treat it like a research platform, we can then publish information about it, right? New results from it, so that other people can also learn from that work and then start contributing to the cyclocopter research in general, right? If we try to commercialize it, and then we would have to stop publishing or open sourcing that information. And so we didn't want to do that. We didn't want to restrict any of that. We wanted to make sure that we're giving back to the scientific community. So that was the main reason there.
Okay, so then another question is, can cyclocopter work in full scale, like a flying car in future?
A full scale? So that's difficult to say because, compared to a helicopter, right, a cyclocopter has a lot of moving parts. So instead of just two, like a single rotor with two blades, for instance, cyclocopter, one rotor has like 4 blades, right? And so it's very difficult to scale it up in the same way. And so there are researchers looking at scaling it up right now, like I said, in Japan, and there's also folks in Texas University. But it's one of the reasons why this worked really well in the small scale is that when you scale down, so it's, if you can imagine, throwing a ball in the air versus throwing a ball underwater, right? It's very different because of the way the fluid moves, right? So something like that is happening at the smaller scale. A helicopter flying, a big, full-scale helicopter flying is very different than a small vehicle flying in the air, because at that scale, because the vehicle is so light, the fluid actually matters. So the fluid is functioning more like if you were, trying to fly underwater, right? So because of that, there's not as much. I guess that was one of the reasons why the cyclocopter design was more efficient at that smaller scale. So it's hard to
Yeah,
see.
exactly. You just mentioned about the fluid, and there is a question about the water here.
Oh, great. Okay.
What kind of changes would be required for this to work underwater? Is that even possible?
That's a great question. So the answer is absolutely yes. Actually, there's the cyclorotor. The initial application of it was actually underwater. So there's a rotor called a propeller called Boyd-Snyder propeller, and it looks just like a cyclorotor, right? So it has multiple blades rotating along that one axis, and they actually use that already on tugboats, so that you can easily change, tugboats. You can change the direction quickly without having to, rotate, maneuver around waves. You can easily just move from move from left to right in one direction easily with a tugboat. So cyclorotors are already being used underwater, and I recently saw that there was a company trying to use the cyclorotor as an underwater like a windmill, right, in order to generate or energy, to collect energy. So these sort of propellers are already being used underwater.
Okay, I hope you answers well. And then I have a greeting from the Vijay Lakshmi Rai. She says Jojalopa in the Facebook, and also one message from Minu Hara. Hi, I am Minu. So watching from Kathmandu. Thank you for this interesting session. Congratulations to Elena for such comprehensive presentations. Well done. So this is the compliment for you from Mina Hara. And then, by the way, I have a questions about maybe. First of all, the question is, so if the parents wants their children to be aerospace engineer, so are you ready to help them, just to mentor them? Okay, maybe the young generation may want to follow you about to be aerospace engineers. How can you help them?
Oh, absolutely. So I'm also available to mentor one-on-one. That's something I'm really excited about. The other thing is, so I've been working on putting together a workshop. So trying, to that will help introduce students or younger kids, high school students, middle school kids, to the world of aerospace engineering and also engineering in general. Because aerospace engineering, while a lot of it is involved focus on the flying vehicle, right? You actually need to know a lot, in order to make these vehicles work, right? From like the structures, like the mechanical engineering to programming, all of those are important in aerospace engineering as well. And so I wanted to put together a workshop that's like hands-on, so that the kids can have a chance to either build their own quadcopter or try to make a rotor move or servos move. So that's going to be coming in the future. Hopefully, I mean, we'll be starting that workshop with NOA in Maryland, but hopefully expanding it as well with WNO and for other countries. So I mean, again, going back to the question, I would love to mentor anyone that is interested in learning more about aerospace engineering. I'm also, can answer any questions or provide any advice or support. And then also for people that aren't fully, I guess, interested yet, but are interested to know more, there are going to be multiple, hopefully, workshops in the future. And I'll try to do a lot more of these sorts of briefs, right? These interviews, so that other people can also learn about the field.
Okay, so hopefully, so how much I mean, it's difficult to get in to aerospace engineer? For example, how much the students can get a scholarship? Number one, and number two is honestly, so many of students may have some problem. How much may have some questions about how much money can make in this aerospace engineering compared to other engineering?
Sure. So I guess in terms of difficulty, I'll start there. It's I mean, the difficulty level is the same as other engineering majors, right? So for engineering, you have to be comfortable with physics, with math. So similar thing, right? It all involves problem solving, and something I want to say is that these skills can be developed at any point in your life. So you don't have to, be born as someone that's very intelligent with math or very capable and competent in physics and math. That's something that you can learn in high school, in middle school, even in undergrad. The first few years is when they teach you those, the physics and math courses. So as long as you're willing to work hard and accept, basically don't shy away from when you might fail. Just keep pushing yourself. The engineering as a whole, field, is very doable, right? It's just going to be a lot of hard work, but anyone can enter the engineering field. So that goes doubly so for aerospace. The other thing is, I guess the other question was about the salary, right? So compared to,
Yeah,
I will
so
say,
everybody has the same, may have some same question. I just represent that
oh,
question for you.
sure. No, that's a good question to know. I mean, you have to think about these practical things before you choose a major. And
Mhm.
so in terms of salary, I have to say, it's not as good as computer science. So right now, if you go into programming, you can it has a lot more flexibility, right? There are a lot of companies that are like major companies like Google, Facebook, that are hiring a lot of programmers, and so they definitely get paid the most. So if you're interested in the pay, then that's where you go. Within engineering itself, aerospace engineering pays quite well compared to mechanical and civil engineering, because because of the skill sets you need, you do learn a lot of different skills. So from, like I said earlier, like from programming to build, manufacturing, working with your hands, like, right, building things, to designing. There's a lot of things that you learn through aerospace engineering program itself in school. And so the pay is, I mean, it's pretty high within the engineering field itself, right? Still, computer engineering or electrical engineering even, and computer science for sure, they will pay higher. But if you're interested more in working with your hands and you're interested more in building vehicles that fly, then aerospace is definitely the way to go.
Okay, hopefully this is the answers for everybody. And I have some greeting messages from Ken Marylander. I think it's a Ken Ranjit. I think good job, Elena. Kudos to you. And also message from Urmila Tamrakar. So yes, proud of you, Murukul. I think I read before. So right, Lotun and Mander has the question. So hopefully it is the last question for today. Okay, Lotun Tata, question
Right. Okay, Elena Ju. I have a question for you. I know you're in aerospace, aeronautic engineering, but I have a question that I request maybe another. Can you develop a fire brigade which can be used higher up? But like in relation to Nepal, in Nepal we have very narrow roads, and if there is a fire, and some that the fire brigade cannot go, is too bulky and too robust. So is there any way that you can build, or anybody can build, fire brigade which is in sort of small to get in, but to go higher up? Obviously you can make it to go up, so that the human being don't have to go. You just go up and then put the fire out. Can it be done? Because in relation to Nepal, we really need that, because if you go to Maru, if you go to Bhaktapur and things like that, the roads are so narrow, and even in the the courtyard and things like that, it's so difficult to get in. So have you ever thought of that? And this probably is going to be a really great idea for me, because I'm not an engineer. So maybe you can think about it, or ask somebody to do it. Could it be done? And then I'll have another question for the aerospace.
Thank you so much for these questions. These are great. So it can be done, and people are already looking at using quadcopters or multicopters, to extinguish the fires, right? Because when you have these multiple rotors, they can support more weight, so they can carry that, the things that you need. It's not necessarily water, but it's the equipment that you need for extinguishing fire. And so absolutely, you can do that. It just means scaling up these vehicles a bit more. So you might have like instead of a 5-pound multi-rotor, a multicopter, you might use like a 20-pound or a 50-pound multicopter. But it can definitely be done. And you're right, that's a very important, especially for places like in Nepal, which the roads are narrower, right? So you don't have as much space to move around with. And so these sort of rotorcraft vehicles are very important there. Yeah.
So can anybody request on that to make it?
Yeah, actually, the great thing about I guess the last few years is that it's how easy it is to do this at home, right? You don't have to work at a research lab to buy the the motors or the propellers that you need, and to assemble this sort of vehicle, right? And so with I guess the open source movement, a lot of blogs, a lot of YouTube videos online, they actually give you tutorials and instructions on how to put together your own kit. So definitely that can be done by anyone.
Okay.
So I have now questions. So we are almost end of the hour. No, over the hour actually. So now my question is different from now your field. So my question is, you are from very core Newa family, and so how did you miss to learn Nepal Bhasha?
No, that's a great question, and definitely a very important one to address here. So this is I think a problem that a lot of immigrant families face, right? When as for parents at least, it's what do you do when you move your family and kids from one culture and introduce them to a new culture, right? How do you still make sure that they are connected to their culture, but still able to succeed in this new environment, still able to communicate well in this new environment. And so I'm not sure. I'm not speaking for my parents. So this is what I think. You know, what I think is that
Generalize, general.
yeah, is
I
that
understand.
is that typically, you know, in order to, you know, try to push your kids to succeed in this new culture, it's important for the kids to learn the new language, to be able to speak it fluently so they can blend in with the new community, right? Otherwise, it's hard to succeed, right? It's hard, you know, especially when you're competing against kids who grew up, you know, they only know English, right? And so they're able to communicate very well, you know, in school, at work, and communication is like the number one skill that anyone needs to succeed in life. And so I think a lot of immigrant families, what they want to do is, what they're doing is they're trying, you know, to let the kids focus on learning this new language first so that they can succeed. And then what's happening after they succeed, and after they graduate, they get to their first job, is that a lot of families are then trying to reintroduce the kids back to their cultural roots, right? Because once you're old enough, you know, you're able to easily switch between different languages. You understand the differences in culture and language communication style, and so it's easier to you know, try to I guess, you know, go back and learn these things again. So at least in my specific case, that's what has happened, is that, you know, even though I was 7 years old when I came here, and I know how to speak Nepali, I know some of Nepal Bhasa, just some a little bit, is that, you know, I was focusing a lot on making sure I can communicate and with, you know, in English with people in the United States. And then now that I'm at that point where I have graduated and I'm, you know, job, I'm going back and learning more about, you know, Newa culture. I'm trying to brush up and speak more fluently, and try to, you know, understand the history of, you know, Newa, and then just in general, like the background of my family, right? So I think and I think that's perfectly fine. And I'm not really sure if I addressed your question fully, but I think it's okay.
No, you addressed
Cycles,
my
right?
question, because I have also same problem. So I know that you are from the Detroit, you grew up in Maryland, right? And now you moved to the Michigan, Detroit, and I'm here in New York. So I have also a son. I am also facing the same problem, because we give the priority first to learn the English language, right? To communicate with other people here in school or college. Yeah, there's no problem. So yeah, you are right. So my question now, another question is now, definitely, even we don't know the language, so you definitely love culture, right? So you are involving in different cultures, right? Which is good. So you have any plan to learn Nepal Bhasa in future?
Absolutely. So I have been trying to be more involved with NOA and also the programs there, and learning more about the history. So as you guys know, my dad, Naresh Shakya, he's a general secretary of NOA. And so, you know, with his encouragement and his support, I've been trying to learn more about the culture, learning more about books and reading watching videos, and trying to speak more, you know, in Nepal Bhasa and also Nepali at home with my parents. And we're doing the same with my siblings, my sister and my brother. And in general, just, you know, trying to reconnect with the community, and very lucky and thankful that there is a big community in Maryland, and there's also you know, my relatives are in Ohio, and there's a community here in Michigan as well. So it's good to see a lot of, you know, Nepali people in the United States, so that we can actually reconnect, right? And so that's what I'm doing, is trying to,
Good,
you know,
good.
learn more
Then
about. Sure.
I have some message in Facebook just from Nishal Pradhan that even in Niwa community in Kathmandu, we see fewer people from the next generation speaking Nepal Bhasa. So the problem isn't specific to immigrants alone. So not only here, in Nepal also the problem, right? Okay, and then the B Nest, I don't know what is his real name. And there's a comment, it's good to know the language, but that shouldn't be a benchmark to someone's love for their culture. there are lots of kids in the US who don't speak who don't speak their parents' language, but they still participate in their culture, heritage, and traditions. Definitely, it is true. It's the same thing happening to me. My son also participate in different cultures, but he doesn't know the Nepal Bhasha. I'm trying to teach him, but it is very difficult, as you said. Okay, definitely, right. So you are I mean, you are good, right, Dr. Elena? So
Yeah.
no problem.
Definitely.
Yeah,
Yeah.
but we shouldn't forget to learn Nepal Bhasha. That's the things. Okay, so the last thing is, do you have any message through our audience through this WDV?
Yes, absolutely. Yeah. Thank you again so much for hosting me here. And I guess a general comment to parents that are, looking to encourage their kids to either pursue engineering or in general just be more excited about technology is that it's very important for parents to be involved too, right? So kids can see, get encouraged by what they see at school, at field trips, but it's more important when parents are directly involved. So if you take your own child to a museum, or you do some experiments at home, that has like more lasting memories for the kids, and that'll be more encouraging for them to see you excited about that technology or that field, right? So definitely encourage more interaction, a joint interaction, not just sending a kid to a camp, but doing those experiments or doing those activities together will really help any parents, to encourage their kids, right? And because that's one of my fondest memories is it's doing these things with my dad and my mom, right? And then also with my siblings. Those sort of memories are what inspires me and excites me to pursue more within the aerospace field and also robotics field. So definitely encourage doing that. And also, again, I have a LinkedIn, and so feel free to reach out whenever anyone that's interested in pursuing aerospace or any engineering field in general. If you have some questions about how do you structure your application for university, how what's the steps of getting a scholarship, or those sort of advice or questions, like, I'm definitely happy to answer them. And in general, just excited to mentor people. So feel free to reach out on my LinkedIn, or I guess I don't know if I published my email, but LinkedIn is the best, or on Facebook if you can reach out there with my dad.
Definitely, who can reach out to you, definitely they may know the LinkedIn, right? It's very
Yes.
close. Okay, thank you so much, Dr. Elena Shrestha, for your time. And so actually, there were so many questions from the audience today, but there were a lot of interactions, which is good. Thank you so much. Okay, यो कोही सोबाटो Dr. Elena Shrestha जो एउटा वेका चाहिँ एरोस्पेस इन्जिनियर ख अले जिसा चाहिँ आज जी ज्याजो न्याकालो ढार न जथो जिगु ज्याजो WD मु आज टे चाहिँ थन जि निवा टेसन यो को ठ्या ठसे चाहिँ पेचे चौ लेभल पेचे चौ चाहिँ त पेचे चुना चाहिँ यो को ज्यान चुना दिगु दु अले वेक अप चाहिँ ना वे चाहिँ ज्याइ चाहिँ फ्याम पोले जिसा चाहिँ वेक अप नि ज्या चुख के ख वेक अप नि विशेषज्ञ त के दु सिकेको वेक अप नि फ्याम पोले इन्फर्मेसन मुंकीको जिगु मु ज्याजो ख तो आज तो ज्याजो मु आज ख एजा जिसा चाहिँ तो आ जिसा गुली निवा दु निवा भए बालका ल्याम सपी मलाई जिता चाहिँ थो कम्प्लेन कम्प्लेन न हो तो WDV ज्याजोले चाहिँ निवा भए मलाई चाहिँ मेमे भएन खेल ढगा तर जिसा चाहिँ वेट आइड अठ्यान्त या चाहिँ ह्युमन आजुले चाहिँ वेक अप पाके इन्फर्मेसन द कलेक्सन या सो मुंके के खटो न अले तर आरके बियान टेख एजा चाहिँ तो थैट ठीक खट पाएट ठीक न स भ्याचले यन नख जिसा फुकन खला वाला चाहिँ अंग्रेजी पाके खला न जी डाक्टर एलेना श्रेष्ठ जुदा यो सुवे विषय point to jazo ko ta ozon pana na wasya nya kane chen chi kane ma paha ka Nepal bhasha manga khala plama na ali se to kipa kalakar baju julum lal chitrkar weka kane chi khana la jazo le jai ji khule da se thoi jazo ko jakte pi pai ozon pana na akhna chaka jojo